And welcome to Faster Faster. Who's met me before, or have I had on a training course or something like that? Okay, excellent. Lovely to have you back. For those that don't know me, and I also want to do a welcome for those that are dialing in remotely, especially internationally, especially my son Quentin in Christchurch. Hi, Q. For those that don't know me, my name is Peter Lovett. I've been a programmer for 41 years. I've been being paid to be a programmer for 41 years. Nowadays, I run training courses predominantly in C, C++, and of course, Python. And you can find me at +plus.com.au. This is not an introduction talk. This is, I'm expecting that you already know Regex, and we're going to be exploring particularly performance. I'd also have to say this is incomplete. I have missed a lot of things. Because benchmarking's tricky. It's a tricky thing to get right. It's a tricky thing to repeat. Here's some of the things that I have found. Specifically, I've done these benchmarks on CPython 3.11.4. On Windows 10, they've been timed with IPython timer. There are a number of issues that are outstanding with some of the things that I'll be looking at, particularly the possessive quantifiers. And if anything goes wrong, it's your problem. I would also say content warning, and I hope you've learned to sanitize your database inputs. This may highlight some deficiencies that you have in your Regex use. I'm getting a bit of feedback there, is that? Thank you. And this is not a security talk. I'm not talking about security directly, but the things that we look at may well have some security or denial of service, particularly implications. What we're going to look at is rule number 1. We're going to look at compiling quantifiers, character classes and flags, backtracking, and then atomic grouping and possessive quantifiers that are new in 3.11. So if you're using 3.10, you should probably get to 3.11. Rule number 1. Does everyone know the first rule of Regex? Shout it out. And rule number 1 is, don't use Regex. To quote Jamie Zawinski, some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have 2 problems. Or this one applies to me. Some people, when confronted with a problem, think, I know, I'll quote Jamie Zawinski. I'm not specifically talking about readability or other issues apart from performance in this talk, but I want to I couldn't help myself. I had to say readability counts, as it says in PEP 20. So first up, don't use Regex 1, don't use match, use starts with, 500% faster. Applaud now. And that's the end of the course. That's the end of the talk. I hope you've got benefit out of it. Whenever you see a % faster that you're happy with, I want some applause. Don't use search, use in. Don't use Regex unless you need to. I could do a match of does it start with an A, B or a C, or I could do a starts with, or starts with. Or a little known, but it's actually pretty handy, starts with takes a tuple. And you get a tiny little bit of improvement there. Go, Pete. Don't use Regex unless you need to. Oh, but Pete, it's got to start with a letter. And I'd rather do that. But it's 500% faster. So now you've got a trade-off between readability and performance. But I want to talk about performance. Oh, actually, why don't you just go and do a range check? So don't use Regex. If you're going to use Regex, you should compile. That's a tiny bit of the code from the RE module. And we can see some interesting things there, that there is a compile function that calls a single underscore compile, and it actually has a cache of all of the patterns. Nonetheless, doing a search took that long, but pre-compiling it and then searching still gave us a drastic improvement. I haven't quite drilled down exactly what I'm getting there, but I did repeat it and I was happy with that. Let's talk about anchors. Don't use hat. You're doing a search from the beginning, and you shouldn't do that. You should do a match, and that gives you 5%. Oh, I should have worked up, shouldn't I? I should have started with the 5% and ended up with the 500%. I've got more though. Stay tuned. If you used a match with the hat, then you do get it's a tiny bit slower. Flags. You say, but Pete, I need flags so that I can do ignore case. No, you don't. Instead of using ignore case, why don't you use a character class and get 17% faster? Really? There is some... Do I get some dissent there? Yeah. I would point out that in non-ASCII there are more details in case than just B or B, but just looking at a straight ASCII alphabet, even if I had to do each one of those letters, it still worked out cheaper, it still worked out faster than straight flags. What about quantifiers? I've got a long string there, lots of A's. If I did a search for one or more anythings, or an A and then one or more anythings and then a C, now I'd want to point out, watch out for your fail cases. The fail case is often a marked difference in your performance compared to, oh, it found it. So this benchmark is I didn't find it, and that gave me that speed. But if I went and clamped it, I got 280% faster. Because you probably don't mean plus, because plus goes from 1 to infinity, and infinity is a big number. So Pete's maxim, don't use plus. Don't use star. Consider exactly what we're talking about there. Consider how many you're after. Let's look at laziness. Now here, tonight, it is almost tonight, is indeed a unique occasion in the history of PyCon. I'm looking for a space in stuff and then a space. Now the sharp amongst you will go, yeah, Pete, but that's going to grab too much. And in fact it does. Because, as I didn't wear it, I need to get a t-shirt that says, quantifiers are greedy. Quantifiers by default are greedy. They grab the most they can, not the least they can. One option grabs all of that through to the space. A nice option there, though, is to make the quantifier not greedy, also known as lazy, also known as reluctant. And that then stops at the first one that it finds, not the last one. Like that. That doesn't actually have anything, doesn't have a lot to do with performance, but stay with me. If I did a search for a greedy quantifier, I get 467 whatevers. Make it lazy, it's a little bit slower. You can now boo. Boo. That's not what we're here for, Pete. We didn't want slower, we wanted faster. Well, maybe you don't mean dot. A negated character class is a nice solution, and for 8% faster. Well, it's not 500% faster, but it's faster. Yeah, I'll give that. If you get an 8% here and a 5% there, you'll get a nice result, which leads to Pete's next maxim, which is don't use dot. You probably don't mean anything. Reminder, dot doesn't actually match anything. It matches most things. What does dot not match? New lines. Unless you got the dot all modifier. I didn't benchmark that. Here's an example of something that I'll be using for the subsequent exercises, which is I'm looking for a sentence. And I've defined a sentence as word characters, followed by a space, maybe, white space, maybe, one or more words, and an actual, real, actual dot at the end. The sharp amongst you will go, no, Pete, you've just committed a fatal error. And if you can't see that, I'll be getting to that. It'll work, it's just got a performance implication. And if I looked for something that doesn't have a full stop on the end, I didn't get the sentence, no match. One thing that I could do is use non-capturing groups. So parentheses, have three different uses. They're used for grouping, which is actually what I'm using it for there. They're used for alternation, this or that. And they're also used for capturing. Now, I'm not doing any capturing here. I don't want to capture. I'm not using \1 or doing a match group. So why not use a non-capturing group? Non-capturing groups are groups. They do exactly the same as groups, but they don't capture it. And it gave me a little bit faster. To be honest, it's a bit uglier. But if you wanted beautiful, this is the wrong talk. Now, in order to go further, we need to understand backtracking and how the engine actually goes looking for things. If I was looking for a one or more A's and a B, it works. If I was looking for one or more A's and a B and it can't find it, it actually has multiple bites at the cherry. It goes back and has another go. Let's do a demo. Love live demos. What could possibly go wrong? So this is Regex 101. Awesome, totally awesome, because they've got this awesome thing down here called the Regex debugger. I mean, it tells you whether you got a match or not. That's interesting. But the Regex debugger gives you an enormous amount of insight into what's really going on here. There's my data, there's my pattern, and here's the steps that it's going through. It found a match in 3 steps. It did the A's, see that highlight, got the B, happy. Well, that wasn't a great demo. Well, actually, I want to show you what happens if it doesn't find it. If it doesn't find it, it failed and took 35 steps. You should be shouting out, what? Because it did that and it didn't find it. So it goes backwards and it's hard to see, there's a tiny little thin blue line there. Now it's going to start there and have another go and didn't find it. So it goes back and has another go. I'm seeing some my Regex is just a disaster. Probably is. And it keeps on having a go until eventually, after 35 stabs at it, it finds out that it didn't find it. That was my demo. So what about bad backtracking? Backtracking, this process of the Regex engine going back to the beginning, having another go at it, moving along a bit, is not too bad in my none shall pass to find the sentence, and it got me a result of that. But if it doesn't find it, it took a heck of a lot longer. But it's how do I say this? It's worse than that. It's catastrophic. That's the only way I could describe it, because if the end of the pattern causes it to not match, if the string that I'm searching is that big, it took that long, add 1 character to that, it's twice as long. Uh-oh. And if it was 1 more character long, it's going to take that long. Will I keep going? And if it was 1 more, it's going to take that long. And if it's 1 more, and that's, I don't know how to tell you, that's not a long string. I'd call that a short string. You can see where I'm going on this? So, we'll call that catastrophic. We could also have a look at what the Regex engine is going to give me for the number of steps it's doing. And yeah. I got to 4 and then it just gave up. It gave me a nah, sorry, Didn't find it, couldn't find it. Catastrophic backtracking. So if I have a look at another demo there of, again, this with a doesn't match, or if there's a, doesn't match, I got 19,000 steps as it keeps on going. And that will be the end of the talk. Hopefully I've got a solution for you. I do have a solution for you. That was a demo. So if the input string length isn't too long, it's fairly flat for if it finds it. But if it doesn't find it, that's when the backtracking happens, and then it goes, well, that's not too bad at the bottom. In fact, found was taking longer, but when the input string gets longer, we've got ourselves a quadratic performance, O of n squared, and that's, how do I say this? Bad. One thing, this one actually suffers from the same problem, but in a slightly different way. I don't know if you can see it, but \w word character includes digit characters. And when there's an overlap of those character classes, you'll invoke far more backtracking. One solution in this particular case is make sure that you don't use overlapping character classes. Make sure they're mutually exclusive. If they're mutually exclusive, then that particular fail won't happen. And even in a simple case, it was 78% faster. Or we could look at atomic grouping. Again, this is new in 3.11. The big thing with an atomic group, and possessive quantifiers as well, is that they don't backtrack. So they don't go back and have another go. So the pattern of, that's a long way up, A, B, C, or B, and a C, would match both A, B, C, and A, B, C, and the C. But the atomic grouping, after it's eaten, after it's chewed through, after it's consumed the BC, there's no C left in ABC, so it will only be a true, it would only give me a match on A, B, C, and C. Because there's no backtracking. And it's slower. Well, again, it's slower in the simple case, but I'm much more interested in the fail case, where for that example, I've got a 26% faster. And they both don't find it, so no problem. Notice the regex extension there. Paren question mark is the whole selection of regex extensions, which Python 3.11 now supports more of because it supports atomic grouping. So the quantifiers, we've got straight quantifiers. I'm just using star there, but it applies to plus and applies to curlies. By default, greedy. Trail it with a question mark to make it lazy. Stop at the first one. Trail it with a plus to make it possessive. So why or where would possessive not be good? If I had a pattern like that, r.star spam, because of backtracking, I get eggs and spam, and it matches eggs and spam. That is, the dot star goes and consumes everything, and then it backtracks so that it doesn't consume it all, so that it does get the and spam. Make that possessive by chucking a plus on it, and it doesn't match. Because the dot star has consumed all of the data string. This parrot is dead. I'm looking for a quoted string, and if I use a possessive quantifier after a dot plus before the quotes, this is the same one I just showed you, it doesn't get the match because the dot plus consumes it. So just a reminder, those pluses are, well, they're the same key on the keyboard, but they've got completely different meanings. The first plus is this is the one or more quantifier, and the second plus is the previous quantifier, the plus, is possessive. So from my maxim earlier, don't use dot, then I could use a negated character class of not quote, make it possessive, I get the right match, and I got 6% faster there. That was a bit of effort for 6%. Stay with me. Let's go and look at something more detailed. My scary one. So this particular one, looking for the sentence in the none shall pass, 1, 2, 3, 4, 5, took 6,790 microseconds. Make it possessive. Yeah! Make it possessive, and we get it down from 6,000 to 2. And if I made this one possessive as well, I got a little bit faster. So I got a... I got a 2,000,000% speed improvement. I thought that was pretty good, actually. So that's like if you were flying to London, instead of it taking 23 hours and 10 minutes, we could do it in 6 minutes. Now, I should put a caveat in there. Not every occurrence of this is going to give you a 2,000,000% improvement. Don't come back to me if you're not getting a 2,000,000% improvement in your regex. I just lost my time. Too long, didn't listen? Don't use regex. But if you're going to use regex, don't use dot. Consider negated character classes. Clamp your quantifiers. Don't use plus, don't use star, use curly brace, from, to, or a specific number. Use non-capturing groups, paren, question mark, colon. Watch out for nested quantifiers. I don't think I used the phrase, but I should have. When I was looking for the sentence, that was the problem, was that I had a nested quantifier. I will just go back to that because I think that was, well, that one's there. That's the problem, is that we have a nested quantifier. We have an unbounded quantifier inside an unbounded quantifier. And it's the nested quantifiers that gave us the catastrophic backtracking and the quadratic performance. So, watch out for nested quantifiers. Use mutually exclusive patterns. That was where I had the \W followed by the \D. Where there's an overlap of the patterns, use mutually exclusive patterns. And if appropriate, and if it works for your problem, use possessive quantifiers and atomic grouping. Technically, they're actually the same thing, that's just different syntax giving you the same, or they're almost the same thing. As long as you've got 3.11, which you should have, because 3.12 comes out next month. I didn't mention it earlier, but I should mention it. Test your regex. As may be obvious, it's very easy to get a regex that is wrong. Test them. And of course, use your own discretion. Readability counts. The details of that, the benchmarks were done on Win 10 with CPython, that particular version, and I used IPython timeit. I'm aware of the deficiencies of that as a benchmarking tool, but if you're going to get 2 million or 2.2 million, I'm happy with either. Your mileage may vary. There's a wide variation in the sort of performance profiles that you will get with these. And it behooves me to mention that there are different regex engines. In fact, backtracking engines like Python users and Perl users and Ruby users are notorious for this particular fail. There are other regex engines. Here I'm just looking at CPython's built-in RE module, but consider other regex engines. There's some on pip. For more information, look at the regular expression denial of service page. That's a thing that any of you that are using regular expressions that parse user data need to be well aware of. Regular expressions info is a fabulous website, a very thorough coverage, and the author of that site kindly added on some Python 3.11 things when I raised it with him. Thank you. Regex 101, and of course, Mastering Regular Expressions by the Jeffrey Friedel, and some of those images were from him, the others were from Quentin. So thank you. Thanks to you for coming to my talk. Thank you to the PyCon AU organisers, volunteers. My wife, who, whenever she sees me writing regex in my study, she says, it looks like I fell asleep and my head hit the keyboard. And I now have a regex. Cody for review, and sorry I embarrassed you again. Quentin, Buddy, the Jeffrey Friedel, who I had a nice interaction with, Jan Govets for adding Python 3.11. There was an XKCD in there and some other images. And that's the end of my talk. Now we have a couple of minutes. If there's anyone that has a specific question that I can cover in a couple of minutes.
We do have a comment from Quentin, I believe. So, guessing that possessive quantifiers are also in 3.11 and later, is that correct?
That's correct, yes. Yeah. Interestingly, the engine actually, because the Python regex engine is written in C and is actually from Secret Labs, I think, originally, it's actually had this functionality, but we just didn't have the Python layer that passed it through. So we've actually had it in the engine for a long time.
First question here.
Just a real quick one. Compiled regular expressions, do they have the same exponential behavior? I really hope they don't, because it's unnecessary.
When you've compiled them, yes, so they still fail. They still have that same performance profile. In fact, the call to RE search actually returns the underscore compile of that. Compile caches, by default, I think it's the last 50 regular expressions. So I was kind of surprised to see that performance if I separately compiled and called it, that I actually got a noticeable a performance improvement in doing that. Traditionally, I'd always be very careful about doing a regex inside a loop. I would always compile before, but the code there now is caching that, so I wouldn't see as good a performance improvement as I used to. Up the back somewhere?
Could you explain possessive regex again? I didn't quite understand it.
Sure. So it's a funny word, because what it really means is, the best one for that is this one. So this particular one, dot star means 0 or more of anything followed by a spam. When it parses eggs and spam, it'll actually read or eat or consume all of it and then go, I didn't find. When it gets to the end, then it says, I didn't get a spam. So it'll start at the front again and go up to one before the end. And then it'll go back and have another go, and then go back and have another go until it finds that it can get a match. That's the backtracking that happens. It's kind of obvious to us as humans, like, don't do that. But by the design of the engine, that's the way that it works. And it's quite amazing that it works anyway. The possessive quantifier possesses it and doesn't. The simplest way of explaining it is that it doesn't backtrack. So once it's consumed everything that it could for the dot star, there's nothing left. So a possessive quantifier tells it to not backtrack. In this particular example, it doesn't give me the match. But the one with the, this one here is a good example, because that will execute faster because I'm using a negated character class.
All right, thank you. That's all we have time for, I'm afraid.
Sorry, if I can just interject. I'll be hanging around, so if you've got any more questions, you're welcome to come and see me after, and or there's my contact at the end, if you would like to contact me post-course or post.
Thank you very much. Here's your speaker's gift.
Yay!